we have. Going back to chapter 5 in this book, we did a little bit of work with files, and we're going to expand that today two different ways. Just a quick review of what we did for files. We had a preprocessor directive of pound include fstream. We did OFstream for output. So we instantiated an object called output file and some operations that we performed on output file. One was to open it and one was to close it. We had to make sure we do both of these. Helps ensure the integrity of the file. A story from a long time ago. I wrote a program for Lancaster Lebanon League cross country meet and had all this data stored, all the names, the schools, their number that they wore on their shirt and where they finished. And I couldn't figure out why the program started to crash. It's because I forgot to close a file and it just messed everything up. But boy, that was on an Apple IIe written in basic language on a 5 1/4 inch floppy disk. I had to save it. So I was there the day of the race, and I didn't input everything. And it did all kinds of stuff, displacers and so on and so on. And but so something was nice input name while input file. I could read in numbers and it would keep going until it found that end of file marker. Okay, so you had that in chapter 5, saw that again in the videos. And what we're going to do today is get into some more advanced operations. We had the F stream, but we're going to take a look at IF stream and OF stream because I can do more with those than I could with just this regular F stream. And again, the F stream, we had to decide, what am I going to do? Am I going to read from it, write, input and output? Okay. So some things that you should have seen. We had these access flags. They were included in your header. For example, open text.text. I want to open this for output. It's just a generic F stream. I want to open it for output. I instantiated the object. I made sure I opened it and closed it. And then something else, whatever it was I was doing with it. The code listings were right on key as far as everything that was being taught in this chapter. Here's one where I want to open it for output and I want to append it. Because a lot of times when I was opening something for output, if it didn't exist, it created the file. If it did exist, it put the file pointer to the very beginning of the file and did a rewrite or an overwrite of everything in it. And there are times where appending would be something that we would like to use. When writing to a file, we had to set precision and set W, set our width, trying to make that file look nicer. Reminds me of grading your program. So many times I'm like, could you just put like 5 blank lines in to break it up? Or could you use the ever popular clear screen? And students that did it, I'm like, yeah, clear screen, it makes it so much easier for me to be grading. And yeah, one of the big common problems in the programs was the alphabetical list. Alpha, yeah. Okay. Um, again, we learn about something, and what do? We pass it and we return it. Here I'm passing it in. I have my prototype. I have the data type, and I'm passing in a reference to a file. Down here in the heading, I know that's coming. So there's a bunch of examples in the code listings that when I say, hey, I'd like you to go do this, everything is really right there and available. This was kind of interesting reading it in. I want to read in an entire line. I'm going to use get line. We can declare a delimiter. Read everything in from the file into a string until you reach that /n. That /n is also known as the carriage return, right? ASCII code 13. What was the character return? excuse me, carriage return. Why is it called carriage return? You get to an end of a line and hit enter, but it's also
Next,
known as CR, carriage return. Go ahead.
next line.
Yeah, but where's it come from? What's the
Carriage
history?
return goes to the next line.
Yep, yep. But here's the history of why it's called a carriage return. When I first started typing on a typewriter, they were not electric. In ninth grade, we had the old flip the top of the case off and tap, 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 tap. Well, there was a bar that the paper was wrapped around. Guess what that bar was called? The carriage. So when I would get to an end of a line, I'd grab the bar that was attached to it, and when I pushed it, it moved the carriage one line up and returned me back to the beginning so I could start my next line of typing. So I did a carriage return so that I could start the next line. How about that? So what do I want to do? I want you to play. Something in there looks like code listing 12.8 is going to be a big help to what I want you to do. I gave you Sonnet 18 in the news the other day for that possible extra credit. I want you to go get that Sonnet 18 and I want you to put it in a data file. Then I want you to read it one character at a time by using gets and only put letters into a new file. So you're going to take that file with question marks and commas, and the only thing I want you to do is get those one at a time and put them in a new file. So the only thing that's there are letters and spaces. That
Okay.
makes sense. You're going to create a file that might say, hello, hello, are you there? It's going to make a file, hello, hello, are you there?
With the spaces.
With the spaces, letters and spaces. All right, let's pause the record. All right, can you share your program, please?
Yeah,
Whoever in your group was typing. Usually you like to type.
I do like to type.
Keep showing task better. Do, 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 do. I'm recording. So yeah, I'm going to share this. Let's see what we have.
Sorry.
That's okay.
Okay.
And we're reading it in and we're getting a character at a time. There's the result. Looks pretty good. We open a file for input, a file for output. We use get to get it one at a time. And if it's an alpha or is a space, then we
Is space. That's what I missed.
oh, okay. So yeah, once again, looking at others' code, it makes a lot of sense. And what seemed to be really, really like a big problem needed to take advantage of the function get, the function put, the function is alpha, the function is space. So cool. Pretty good job. Great job.
Thank you.
Not a lot of lines of code. Other groups, any questions?
No, I
Okay.
just missed the is
Yeah, there was
space.
something about the like the apostrophes. I was told that they wouldn't really work in the like the if I were just to just copy paste them
Oh,
like on my peers, so I had to like go in and manually change them. Is that true?
not that I know of. Yeah. Wonder what happened there. Did you have an apostrophe in your data file, Kaylee?
In my I mean the
Um,
sonnet file, like the I just copy pasted it and then I was told, no, 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 you can't use the apostrophes because they'll mess it up.
No,
Or
she
you can't include the apostrophes because it'll mess up in the code. And like I don't know if that was
um,
true or not.
it's
yeah, I
not
don't
because she
think
used
so.
Kaylee, you
Um,
Yeah,
just put it into a um notepad.
Yeah, like a
The
notepad.
text file, you want me to
Yeah.
put this into Notepad?
Is that what you put it in?
Yeah, put it in notepad.
Yeah. No, that should work.
No, I just made a TXT from inside VS Code.
Oh, okay.
Yeah.
Oh, that's another
It's
way.
basically the same.
It's still, yeah, it's still a text file editor.
Yeah.
So, yeah,
Yeah, it
now you
is.
couldn't use Word or anything like that because that throws a lot of special characters in that
Oh
would
yeah, I
mess
mean,
you up.
Yeah, it does.
Okay,
Different file types.
unshare or whatever it is you call.
Yeah.
Stop sharing. Come back to me. Now, the second part is this last section, and it's something new. So that's why we're spending the second half of the class on this. And it's working with a binary file. So Kaylee just created our input file by just using a text editor. Problem is, it's slow and it's problems with conversions. So what has happened is we were able to store things in a different called binary format. And it's known as, you can see, raw data. And it's a matter of learning the syntax to work with it. And as you see, there's a big highlight here with this access flag. And what are we doing? We're passing in the address. And we're going to work with this size of. It's a function that tells me the size of. In this case, we're working with a letter, which is the char, which should be 2 bytes. So depending on what data type goes in here, gives me a number, and it lets me know what I'm working with. Now, I want to work with chars. So if I'm not working with chars, then I have to do this crazy kind of conversion down here at the bottom. And again, there's an example in code listing 1214 where we have to recast it as a character. So if I'm working with X as an integer, I need to turn that into, boy, it's a whole mess of going on, but we have to change, we have to cast it so we can work with a binary file. Okay? So again, it's all about the char. It's all about the char. No, that's money. Money. All right. Hopefully you watch the videos, you're ready to go, and you have the code listings because you typed them in, so you have a little bit of an idea of what's going on. So I have a file that is available under the news. Okay, it's a binary file. You need to read it in as a bunch of characters. But when you read it in as a bunch of characters, you may see this I, J, N, P, N when you display it. And you're like, what is this? I don't understand what that is. Well, I also threw in a Caesar shift. And a Caesar shift is where the letters are actually shifted left or right by, I don't know, based on their ASCII number. So if I would take that I and I want to do this cipher, I want to maybe add 1 to its ASCII value. And if I add 1 to I would actually get a J. So that message would be nothing. If I subtracted 1 from I get H. If I subtract 1 from J, so you're going to read in this binary file and display it. But when you display it, the message isn't going to make sense. You're going to have to like add 1 to everyone or subtract 1 or mess around with this so you can see what the secret Caesar shift is to get what the message will be. Now, the message isn't going to make sense because the last time I did it for 14 weeks in a semester. So there were actually 28 classes. We're doing 14 weeks once a semester. So when you see it, you'll get the idea of what's going on. But I can just take a character and do plus plus. That would add 1 to it, change that C to a D. All right. So you go find out what that secret message is. When you find it, call me in and let me see what you got. And then we're done. So binary file, code listings, starting at 12 13. You type them in, and one of those should be a big help to what I want you to solve. Are there